So today we're going to learn another technique for doing stoichiometry problems. Now this technique called the stoichiometry box, I believe really doesn't get you a full understanding of how stoichiometry works using the factor label or dimension analysis method. However, for those students that are struggling, it is a useful tool for getting the proper answers to stoichiometry problems, albeit it's a little bit tedious. However, when done right, there's only very little simple math, and most of the information you need to do is just basically set up the equation by filling the correct box. So let's see how it works, and hopefully will help those who are really struggling with the concept of stoichiometry. So here's how you do a stoichiometry problem with the stoichiometry box. Now there's a lot of information on this page. I'm not going to go through all of it, but basically the stoichiometry box is a table, and you do the calculations in the table. Across the top of the table, each column represents a reactant or a product. Down the side, or the left-hand side of your table, you are listed things like molar ratio, coefficients from balanced equation, number of grams, molar mass, number of moles, etc. When you fill in all the information that you know from balanced equation, molar masses and all that, plus the information that you're given, by doing simple multiplication or division technique, you can get the answers to all the boxes in the thing. Now let's see how this works in our next example. Okay, so here's the box or the table as I mentioned, right? And here's my example. I'm going to react H2SO4, which is sulfuric acid, with calcium hydroxide. And I'm going to make calcium sulfate and 2 moles of water. Now, when we list all these things, on the left-hand side again is this laundry list of stuff here. Formula, magic ratio, we'll talk about that in a second. Coefficient, that's from your balanced equation. Number of moles, molar mass, and mass in grams. Now, reactant 1 would be H2SO4. Reactant 2 would be calcium hydroxide. Product 1 would be calcium sulfate, and product 2 would be water, right? And I'm going to show you how this is set up in the next slide. But here's our problem. If we have 200 grams of calcium hydroxide, which is this, how many grams of this do we need, sulfuric acid, and how much calcium sulfate and water do I make? Okay, so step 1 is to insert all the information that you know in the box. So we know what the reactants are. So reactant 1 is H2SO4. We put that there. Reactant 2 is calcium hydroxide, calcium sulfate for product 1, and water for product 2. Now remember, we don't list the 2 for water. It's just water. Magic ratio, that's blank. We don't know what that is yet. Coefficient from our balanced equation, we put those in. 1, 1, 1, and then we have 2. 1, 1, 1, 2. So H2SO4, 1, calcium hydroxide 1, etc., etc. Then we calculate the molar masses for each one of our products and reactants. So it's 98 grams for H2SO4, calcium hydroxide is 74.1 grams, calcium sulfate is 136.14, and water it's 18. Now the last thing we need to be put into the table is what we are given. And we are given 200 grams of calcium hydroxide. So we put that right here. This is our mass, and we put that right here. Now from here we're going to do mathematics to get all the other information in the table. Now you're going to say, well, there's a lot of blank spaces. How do I do that? And I'm going to show you how to do that on the next slide. So I've entered all the information. Now we're going to do the math. If you remember, when we move up a column, we're going to divide, and when we move down a column, we're going to multiply. Now, which column do we start with? Well, we have to start with the only one that has grams in it, and that is our calcium hydroxide. And we're going to use this information to be able to fill in the boxes for the rest of this stuff. So let's try it out first. Now, remember, we're going up, so we're going to divide. So I take 74 and divide it into 200 to give me the number of moles. Remember, the mass, molar mass divided into the mass gives me the number of moles. So when we do that, we get 2.7. And then we take the coefficient and we divide that into the moles to give us this thing called the magic ratio. So that's 2.7. Now the magic ratio is the same for every product and reactant in this particular case, in this particular reaction problem. So we're going to say that it's 2.7 here, it has to be 2.7 here, and it has to be 2.7 here, and it has to be 2.7 here. Now that's the tie-in. So once you get the magic ratio for all of the things, now you can do your math down to get all the rest of the information. So now we're moving down, we're going to multiply. So let's start from here. We're going to do 2.7. And then we'll do down here 2.7. And then over here it's 5.4. We could put O. Now we're going to take 2.7 and multiply that by 98, and we're going to get 264.6. We already have the number of grams for calcium hydroxide. Now all we're going to do is this one is just 367.6, and the last one is 97.2. So there you go. Now we have all the boxes filled in. All we did again is once we found the information in this box complete, we used the magic ratio, which was the same for everything, and then we can multiply down to get the remaining information. So now there's a double check of how you if you did it right. If you take all of the masses of your reactants, so in this case we have reactant 1 and reactant 2, if we add them together, they must be very close to product 1 and product 2 masses, within a half a gram. Remember, there's a little bit of rounding and things like that when we do molar masses and all that. But if you do it and you're very close, you can say that, yes, we did it correctly. So if you add these up, you get 464.6, and if you add these up, you get 464.8. So very close. Again, there's a little bit of rounding going on in both of these. Okay? So that's pretty much the simplest way we can do it. So there's again, not a lot of math. Divide up, multiply down. Magic number is the same for everything. This is just an answer sheet based on what we just did. So problem number 2 is asking us if we react nitrogen gas with hydrogen gas to get ammonia gas, if I have 65 grams of ammonia gas made, how many grams of nitrogen and hydrogen do I need to make 65 grams of that? Right? So let's look at this. So we're going to set it up, right? Our formula here is 1 mole of this, 3 moles of hydrogen, gives me 2 moles of NH3. Okay? So let's look at the next page of how we set that up. Okay, so I've put in all the information that you would need to do, right? So again, here's my reactant 1. Here's my reactant 2. Again, I don't put the 3 there, I just leave it. This is my reactant. This just tells me how many of those in my my product 1. Again, do not put 2. There is no product 2, so you just leave that column blank. Right? I fill in all the coefficients from the balanced equation. So there's a 1 here, we put 1 there. For hydrogen, we put 3. For ammonia, we put 2. Calculate the molar masses of each one of the products and reactants. Nitrogen is 28, hydrogen is 2, and ammonia is 17. Now we're given 65 grams of ammonia, so we put that here. We're going to calculate all these other things, right? So what we got to do first is we're going to calculate, again, how many moles of ammonia I have, and that would be 3.82. Through 3.82, I divide that number by 2. Remember, the coefficient divided into the moles gives me the magic ratio, and then that magic ratio is the same all the way across. Okay. Now we're going to multiply down to get the rest of the information that we need. So 3 times 1.91 is 5.73. 1.91 times 1 is 1.91. All right, now we're going to multiply these two numbers together to give us the mass of grams, and multiply these two numbers together to get the mass of grams. So when we do that, we get 11.46 and 53.48. All right. Now, did we do it right? Let's see. If we add up these two numbers here, does it get us close to, very close to 65? So 53.48 plus 11.46 is 64.94 grams. So very close to that. Again, we did some rounding, right? So again, to solve these problems, find the column that you're given the information, most of it, and the number of grams. Do the math as you need to. Remember, as you move up a column, you're going to divide. So you're going to take the molar mass, divide it into the number of grams to give you the number of moles. Take the coefficient, divide it into the number of moles to give you the magic ratio. The magic ratio is the same for all the reactants and products, so you're going to write that all the way across. Once you get that information, then you can multiply down. So for hydrogen, we're going to multiply 1.91 times 3 to get 5.73. That's the number of moles. Multiply the number of moles by the number of grams, the molar mass, gives me the actual number of grams I need based on 65 grams. Going to nitrogen, the magic ratio times the coefficient based on our balanced equation gives me the number of moles I need in this particular reaction. Multiply that by the molar mass. Number of moles times molar mass gives me the total number of grams I need based on the start point of 65 grams. Finally, do your check by adding all the reactants together, masses, and all of the products together, masses, and see if they're the same. Again, this is just the answer key from what we just did. Okay, so now you're going to try it, right? So you're going to use this balanced equation. Iron plus oxygen gives me ferric oxide, or Fe2O3. You're going to fill in the columns here, do the math as I instructed you before, and see what you get for an answer. Now, you are going to react 100 grams of oxygen. So you're starting with 100 grams of oxygen, and I want to know how much of this you're making and how much iron that you need. So when you're ready, stop the video, work the problem, and then come back when you're ready for the answer. So stop the video now. So here are the answers. You should have gotten this. Again, real quick, you start out with 100 grams of oxygen. You divide by 32. Remember, oxygen is O2, not 16. That gives you 3.13. Divide that by the molar coefficient, and that gives you 1.04. I mean, there's a little bit of rounding here. So 3.13 divided by 3 is around 1.04. That's the same. 1.04 is the same for everything. Once you get that, you're going to multiply down. So 1.04 times the coefficient here gives me this number of moles times the molar mass of Fe2O3, or just ferric oxide, gives me this number of grams of ferric oxide. We do the same thing for iron. 1 mole, 1.04, the magic ratio, times 4 gives me the number of moles of iron that I need. Multiply that by the molar mass of iron, gives me the number of grams of iron I need. Add these two up, and they should be very close, within a gram. Right? So again, red information is given or known. The purple answers we calculated. If you're still struggling after that, you should come in and find me.